Hello my dear students. Today we will be studying about equations of motion, which is the topic of chapter 8, motion. So let us start. There are three equations of motion which we will be studying. These three equations are v is equal to u plus at, s is equal to ut plus half at square, v square minus u square is equal to 2as. So all these three equations, first of all the question is, why basically do we need such difficult and tricky equations? The answer is, if suppose a body is in accelerated motion and then we have to find out distance and speed, we cannot go by using a simple formula, that is speed is equal to distance upon time. In that case, we have to use these three sets of equations. While doing numericals, you will get to know how to find various physical quantities by using these three equations of motion. So, we will be using a graphical method to find out or to derive these equations. Let us first start with the first equation of motion. This is the graph which we will be using to derive all the three equations. Let me first explain you about this graph. This is a velocity time graph. Here, the body has at time t is equal to 0. The body has acquired a velocity a, which is also called velocity, initial velocity. We denote it by symbol u. When the body has at time c, the body has acquired a velocity v. So, initial velocity of a body is u and final velocity is v. In order to acquire final velocity v from initial velocity u, it has taken total time t. So, by using this graph, let us derive all the three equations of motion. Let us first start with the first equation of motion. So, we have already studied the formula of acceleration. It is v minus u divided by time. If we multiply it, cross multiplication, you might have studied in mathematics how we cross multiply. If we cross multiply, this denominator time will go to the numerator. We will get at is equal to v minus u, and when we bring this velocity to left hand side, we will get v is equal to u plus at. So this is your first equation of motion. Now let us come to second equation of motion. Second equation of motion we will derive by using distance travelled by the object. When we were doing graphical representation of motion, I taught you that if we have to find distance from a velocity time graph, we always take area under the graph. Now let us come back to that graph. In this graph, we have to find distance travelled by a body in time t. Distance travelled in time t. Now how will we do that? We have to take area under this line. If we have to take area under the line, we have to take this portion, area under this line. Now this is actually forming a triangle and a rectangle. Now first of all, see in the triangle. The area of triangle is half base into height. Now in this triangle ABD, our base is AD. AD is equal to T. So this will be equal to half T into height of this rectangle. This is the height of the rectangle. Height is equal to V minus U. So this will be height is equal to V minus U. So this is the area of rectangle, half t into v minus u. Now coming to this is the area of triangle. Now coming to area of rectangle. Area of rectangle is length into breadth. Now we come to rectangle OADC. In this rectangle, length is OC, that is length is equal to T, and breadth is OA. OA is equal to U. So area of triangle is half T into V minus U, and area of rectangle is T into U. Now let us come back to second equation of motion. As I have explained you that distance is the area of rectangle OADC and area of triangle ABD. So S is equal to U into T, which was the area of rectangle, and half T into V minus U, which is the area of triangle. So when we solve this thing, we will get S is equal to UT plus half T. Instead of V minus U, we have written here AT. How come? V is equal to U plus AT. This was our first equation of motion. So V minus U will be equal to AT. So we have put, instead of V minus U, we have put here AT. So when we will solve it, we will get S is equal to UT plus half AT square. So students, this is your second equation of motion, which we have derived by taking area under the VT graph to find the distance travelled by the object. Now let us come to third equation of motion. Again, the third equation of motion we will be finding by taking area under the VT graph. But here, instead of taking area of triangle plus area of rectangle, we will be taking area of trapezium OABC. Let me show you again that graph. This is the graph. This OABC, this is also forming a trapezium. Now in a trapezium, let me erase this first. In a trapezium, if you remember, the formula of area of trapezium is half sum of parallel sides into height. This is the area of a trapezium. Now in this trapezium, if you see, what are the parallel sides? Parallel sides are, these are the two parallel sides, 1 and 2. So first side is equal to U, and second, this entire thing is equal to V. So it will be half U plus V. Now what is the height? This thing is the height OC. This is your height. This height is equal to time T. So area of trapezium is half U plus V into time T. Now let us come back to our derivation. Third equation of motion. Distance is area of trapezium OABC, which is half sum of parallel sides into height. As we have discussed, S is equal to half U plus V into T. So till here we have come. Now what we will be doing? We will be using first equation of motion. According to first equation of motion, V is equal to U plus AT. So V minus U will be equal to AT, and time will come out to be V minus U divided by A. Now what we will be doing? We will be putting the value of T in the previous equation which we had found out. If we put the value of T in this equation, we will get something like this. S is equal to half U plus V into V minus U divided by A. What we will do now is, we'll take this A to the left hand side. By cross multiplication, A and 2, these two things will take to left hand side. This will become, by cross multiplication, we will get it as 2AS, and the right hand side will be V plus U into V minus U. You might be knowing this formula in mathematics, that A plus B into A minus B is equal to A square minus B square. So we will write it as V square minus U square. This is our third equation of motion. V square minus U square is equal to 2AS. So let me just brief up here. First equation of motion, which is V is equal to U plus AT, and this equation we found out by using the formula of acceleration, which is a is equal to v minus u by t. ठीक है, by simple cross multiplication you will come up to this equation. Second equation of motion is s is equal to ut plus half at square. This equation we have come up by taking area under the vt graph. We started with finding the area of rectangle plus area of triangle, which was equal to distance travelled. Third equation of motion is v square minus u square is equal to 2as, and this equation we have derived by using area of trapezium and making it equal to the distance travelled. Okay, now let us do few numericals based on these three equations of motion so that you are more thorough with the topic. First example is a bus starting from rest. Rest means u is equal to 0. Accelerates in a straight line at a constant rate of 3 meter per second square. Now students, if you have any confusion that what is this 3 meter per second square, rather it is clear from the statement that this is the acceleration. But still, if you have a doubt, you see its units. Meter per second square is the unit of acceleration. So this 3 meter per second square is the acceleration for 8 seconds. 8 seconds will be your time. Calculate the distance travelled by the bus during this time interval. So always we start the numerical by writing what is given to us. Given is, if the body is starting from rest, u is 0, acceleration is 3 meter per second square, and time taken is 8 seconds. What we have to find is the distance travelled. Okay, so what we will be, we have to use such equation of motion from the three equations in which only one thing is unknown, rest all things are given to us. Now see here, we are given with u, a, t, and we have to find s. So the most appropriate equation to use will be the second equation of motion. Why? Because all the right hand side is given to us, we just have to find the left hand side. So by putting values, we will be easily able to find the distance travelled. Okay, second question. A car starts from rest. As soon as you see rest, you put u is equal to 0 and acquired a velocity of 54 km per hour in 2 minutes. So this velocity, because this initial velocity u was 0, so v is the final velocity, which is 54 km per hour. 2 minutes is the time taken. In order to acquire a velocity of 54 km per hour from rest, a body took 2 minutes. What we have to find is acceleration and the distance travelled by the car during this time. Okay, now let us start by writing what is given to us. U is 0, V is 54 km per hour. Time is given in minutes. So what we are going to do is, first thing is we are going to change this into SI unit. If we have to convert kilometer per hour into meter per second, we have to multiply it by 5 by 18. We will get it as 15 meter per second. Now time which is given to us is 2 minutes. So if we multiply 2 minutes by 60, we will get in seconds, that is 120 seconds. So u is given to us, v is given to us, and time is given to us. What we have to find is acceleration and distance. Acceleration we can find by using the simple formula of acceleration, which is v minus u divided by t. Acceleration is v minus u by t. We know the value of v, we know the value of u, and we know the value of t. By putting all the three values, we will get the value of acceleration as 1 by 8 meter per second square. Next, what we have to find is the distance travelled. So distance travelled we will be finding by using the second equation of motion, because in that the entire right hand side is known to us. So we'll put the value of u as 0, half acceleration we just found out 1 by 8, and time is 120 seconds. By putting the values and solving, we will get the distance travelled as 900 meters. Alright. Now let us come to the final numerical for today's session. Velocity time graph given below shows the motion of a cyclist. Find its acceleration, velocity, distance covered by the cyclist in 15 seconds. Alright, so we'll have to first see what type of graph is given to us. This is the graph which is given to us. It is a velocity time graph. He has asked us to find acceleration, velocity and distance traveled. These three things we have to find. What is given to us in the question is the time. Time is in 15 seconds. 15 seconds. So here you will see 15 seconds. This is the time. You have to find acceleration, velocity and the distance. First and foremost thing, acceleration. By looking at the graph, first and foremost thing which you get to know is the body is traveling with a constant velocity. The velocity is not changing with time. When time was 5 seconds, then also velocity was 20, 10 seconds, then also velocity was 20, 15 seconds, again the velocity is 20, so velocity is not changing. Acceleration is the rate of change of velocity. If it is not changing, then acceleration is going to be 0. Okay, next what he is asking for is, what is the velocity? Velocity, very clearly it is shown in the graph. Velocity is 20 meter per second. Then is how we have to find is the distance traveled. For distance traveled, we'll have to take area under the VT graph. From a VT graph, you remember how can we find area, how can we find distance traveled? It is found by taking area under the VT graph. Now this shaded portion, you have to find the area of this thing. This becomes a rectangle. Area of a rectangle is length into breadth. Length here is this thing and this thing. 15 multiplied by breadth here is 20. So distance covered is 20 into 15, that is 300 meters. Okay students, so we are done for today. Our next topic will be circular motion. Hope you had a nice learning. Thank you all.